Start recording now. Okay, so if there's no, so I can't see, if you're typing notes or in the chat or anything, I can't see that right now. Okay, so what I was gonna do is, first just do the proof with a truth table the long way, right? Just to remind you of how to do it. And then right with it, I haven't really done that, is do the shortcut method with it so you can compare, so you can see actually what we're doing. I thought that may be useful. So it's both review, but it's also maybe you'll see a connection between doing it the long way and then how it ends up working out when you do it the short way, right? How does that actually work? Sometimes if you're trying to think about it and you don't totally get it, it might seem kind of mysterious as to why the shortcut method works. So maybe this will help clarify it a little bit. So if this was on the test and I said, can you do a truth table to check for validity, right? Your first step would be just to look at what variables there are. How many are there? Well, there's just two in this case, right? So that means we're just going to look at four different scenarios. Right? If there was an R in here or another variable, an O, then we'd have to look, then we'd have to look at 8 different scenarios. But we don't have to do that. There's just the 2 variables, so we can even just write down those 2 variables right here and do that sort of, that just basic truth table where you go T, T, F, F, T, F, T, F, right? Because there are 2 simple statements, and when you have 2 simple statements, they can either be true or false, right? So they can both be true together, they can both be false together, or one is false and that one's true, or this one's true and that one's false, right? That should be review at this point. So I just put those on the left. It's not really part of the equation, right? It's just reminding yourself of all the possible truth values for P and Q together, right? And then you go through line by line, right? You go through quadrant 1, quadrant 2, quadrant 3, right? And what are you looking for? You're looking for a gremlin, right? You're looking for a gremlin. And again, a gremlin is where you have all true premises and a false conclusion, right? I came up with a little rhyme for this. True is often in green, right, and red is often, and false is in red. So you got to think, what does a gremlin look like? Well, it's got red premises and a green conclusion, right? Tail of green, head of red. That's what you're looking for. You're looking for a creature that has a red tail, all red, right? Each premise is false, and a green head, a red head. Sorry, I completely messed that up. I mixed up my truth and falses, which is exactly what you have to be so careful not to do. Let me say that again. Tail of green means all the premises are true. Head of red would mean the conclusion is false. Right? That's what you're looking for in each of these quadrants. Does that make sense? I hear somebody saying something, but I don't think it has to do with the class. So.
That makes sense.
Okay, so that's what you're looking for, just to get a visual in your head of, oh yeah, I'm looking for a gremlin. What is that again? Okay, can you turn off the mic? So I hear somebody talking with a mic on.
Bonnie, you might want to mute your mic.
Okay. So then we're looking in each of the corners, right? There's 2 variables, so there's just 4 corners to look at, 4 quadrants, right? If there were 3 simple variables, simple statements, then we'd be looking at 8 different possibilities. I haven't made you do that because that's a lot of work, and you can just do it this way. So then you just go through each possibility and fill in the values for that possibility, right? So the first quadrant is always where P and Q are both true. So I just go through and put a true underneath each of the P's and the Q's, right? And then you go in and fill in the rest of the values, right? So for example, not P is pretty easy, right? If P is true, then not P is going to have to be false, okay? And I can circle that. And in fact, I'll circle this one too, because this is just the truth value of the whole conclusion, right? The conclusion happens to be just a single simple statement. So I'll circle that. in the prezzies, I'll have it bold when I do that, right? Some way to make it stand out so it's easier to read, so it's easier to see if you got a gremlin or not. P or Q, well, hopefully you know from your truth tables, right? If at least one side of a disjunction is true, then the whole statement is true. So what we got here is not a gremlin, right? No problem on this in this quadrant. We did not find a gremlin. Otherwise, you would have seen a T, and an F. You would have seen a green tail and a red head. Okay. So now let's do the next possibility. This is where P is true, but Q is false. Okay. So I'll just put a T for each of the P's, and a Q. Underneath the Q, I'll put an F. And again, I can right away circle this one because I don't have to interpret a connective or anything like that. There's just a symbol variable just like before. And then I go over to the second premise where P is true. This is always easy to do. When you have a negation, you just flip it and circle it. Okay. Then we get down to this one, P or Q. Now in this case, Q is false, but that's fine because, again, if you look at your truth table for a disjunction, or if you just remember, right, an or statement is true as long as either side is true. So in this case, P is true, right? It's as though I said it's either sunny or snowing, and guess what? It was sunny. So I was right. Okay. No gremlin. Pretty close to a gremlin, but it's not a gremlin, right? We have a T and an F, but this second premise here isn't true, right? We're looking for the logical possibility that two premises might be true and the conclusion false, but we're not finding one, so that's good. Right? Now we do the same thing again. We're going to make P false, and this time Q is true. Q true. I can circle this. This is easy to flip around, right? And now this time the P is false, so the negation will flip that around and instead be a T, right? Whereas before I turned it into an F because P was true in those cases. Right? But now we have that. Okay, and then we can fill this in. Again, we have one of the disjuncts being true, so that makes the whole thing true. Circle. We got a T and a T. Tension is mounting. Do we have an F? Do we have a head of red? No, we do not. It's true again. So that's fine, and this is what you want, right? So hopefully you see that this is a disjunctive syllogism, which is always valid, right? P or Q, not P there for Q. So you know that if you feed it true premises, you will get a true conclusion. That's what you want out of an argument, right? So you don't have to worry about the internal stuff at all. You just know that if you are feeding it truth, it'll spit out truth, right? Let's look at one more scenario and see if anything changes for the last row. Right? This time, this is the scenario where P and Q are both false. Let's look at that logically possible scenario. Let's look at that quadrant of logical possibility, right? Easy. Let's go F, 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 circle. If P is false, then not P is true. Okay. And if both of the disjuncts are false, that's the only time that a disjunction is false, right? If I say it's snowing or it's sunny and it's neither snowing nor sunny, then I said something false. Okay. So hopefully this is getting to be really review for you, right? That you understand the truth table of a disjunction. And notice that if you look at your truth table for a disjunction, this is exactly what it looks like, right? Because we disperse the T's and the F's in the same way as you do for a truth table. So this is just exactly what your truth table would look like if I were to ask you, define the disjunctive connective, define the disjunction using a truth table. This is exactly what you do, right? That's what it looks like. Okay, but do we have a T and an F? No, we do not. No gremlin, right? Checks out. So that's a fine argument then. Yeah? Now, what if we were to do the same thing with the shortcut method? Right? We have the same setup here. Now notice, we already know that this is valid, but if you were just to look at this and you realize that what you're looking for is a gremlin, you already know you're not going to find a gremlin here, right? Because this has not a red head, but a green head, right? A gremlin is when you have a false conclusion and true premises. So this line right here just is useless to us, right? We can simply ignore it. Same thing with this one right here. This does not tell us. We already know there's not going to be a gremlin there. Gremlins will have a false right here. So now we have got these two possibilities right here. We have Q being false, right? That's what we want to look at. So right down here, I'm just going to say, okay, well, I'm looking at one of those scenarios. I'm not looking at this one or this one. I'm only interested in the one where I have a red head. Right? I'm only interested in the ones where the conclusion is false. So let me look at a scenario where the conclusion is false. Just like that. Right? That's all we're doing, is we're just starting to write down either this row or this row. Yeah? We're starting to write it down. Now, of course, if we have Q being false, then of course it's going to be false over here as well. Which you'll see the same thing here, right? We're looking at this line, Q is false, or this line, Q is false, right? So it makes sense for Q to be false. Then, if you remember the next step is to try to make your conclusions true, right? Well, you can do that if you look over here and here. You can see in which case is the conclusion true, right? It's right here. That's what you're looking for, right? Again, you're not looking for a red body, a red tail, right? You're looking for a green tail and a red head, right? We've got our red head here for sure. Now, can we see if the rest can be made into a green tail? Well, so far, this is promising, right? And this goes along with what I said. Always do those simple ones first, right? The forced choice, when it's either a variable all by itself, right? If this was just P, you could easily make that true. Or if it's not P, that's easy to make true as well, just like this. And we circle it. And notice that when we're in that row right there where not P is true, then of course P itself is going to be false. Right? And that means, of course, once you have a value locked down, you got to transfer it over. You could also just look and you could see that it's the same. And then, of course, we know that we're looking at this line, and we know that both of the disjuncts are false, so that makes the middle value false. You see that? So it doesn't really matter which one we wanted to go for first. We could have gone for this one first, right? But it's easier to do these simple ones first, right? It's always easier that way. And either way, they all need to be true. So regardless, this is going to have to be made true. So I might as well start with the simple one. Okay. So do you see what you end up with the shortcut method? It's just the lines of the long method, right? The truth table, where you have a false conclusion, because that's the red head. That's the giveaway for a gremlin, right? It's as though its little red head is poking out. You want to check inside, right? That's a better metaphor than it's marked on the door. You see a little red head peeking out of the bars in a door. I don't know what this scenario this is, but you want to see, is the rest of the body green, right? Is it a bunch of truths before that? Well, in this case, there's not, right? We already found that out here. We found out the same thing right here, right? Checks out. We cannot work our way backwards and create a logical possibility where all the premises are true and the conclusion is false. Just did not work. Okay. Let me check on you for a second here. I'm going to go back to the regular screen. Okay, Cassandra's here, Connie, Maggie, and Rachel. Okay, good. Is that making sense?
I think it's making sense.
Okay, yeah.
Do you think you could maybe zoom in? Oh, I'm sorry to ask. I know it's pink.
Yeah,
maybe zoom in a little closer, or is that possible?
I could try, but it's not really. The only thing I could do is on the next page, I'll lower it. I'll just tear it off and lower it. You have it on full screen, right?
Yeah.
Okay.
I'm sorry.
Okay, yeah, for the next one, I'll do it a little bit closer so you can see it better. Okay. If I put it lower, then I'll be able to adjust. Just give me a sec here. There, is that better? It looks better to me.
I think so.
That's about as good as I can get it, though.
Yeah, that's better.
Okay.
Thank you.
Yeah, no problem. You know what? I could actually stack it up a little bit higher. 1 minute here. Stick another book underneath of it. Okay, I'm just going to do the same thing. This is a really simple one. Okay, but you know, if I were to ask you, can you do a truth table, the long method, to check for validity? You would first look at how many variables there are, right? Because that tells you how many possibilities you need to look at. And again, if there were 3, then there'd be 8 possibilities. If there are 4 variables, there'd be 16 possibilities. Luckily, there's just 2, so that means there's just going to be 4 possibilities, right? Just like before. And we'll just take our P's and Q's the same way. We can put them over here to the side just to remind ourselves of the different possibilities that there are, right? So you go T, T, F, F, T, F, T, F. So you can once again see that each of the logical possibilities is represented, right? It's like flipping 2 coins. How many different ways can they land? 4 different ways if you have 2 coins. It's the same thing with sentences and truth values. If they can be either true or false, there's 4 different possibilities for each of them, right? And then you just fill them in, fill each one of them in accordingly, right? P is true, Q is true, Q is true, and P is true. I can circle that one because it's done. I've got my truth value for the conclusion locked down. Oh, look at that. I can circle this one. This one's already done, right? It's already locked down. It's not, there's no negation in front of it. It's not part of anything bigger, so that's easy. And then here, you know, if you don't remember, right, this is a conditional. Conditionals are only false when the antecedent is true and the consequent is false, right? In all other cases, it's true, so it's going to be true in this case as well. Again, if you don't know, then consult your truth tables, right? And this gives us the truth value of the whole premise. Do you remember that, right? Right here, this is a comma. And that means all of this is a premise, right? P is not a premise right here, and Q is not a premise right here. The whole premise is if P, then Q, right? Sure, Q is a premise here, and P is a conclusion. But just remember, right? This is the whole premise, and so that's what you circle. Right? So we have a T, T, and a T. Okay, well, that sounds promising, right? That sounds nice. We feed a truth, and it spits out truth. That's certainly what we want from valid arguments. But remember, valid arguments only do that. Valid arguments are reliable, so that when you give it truth, it'll always spit out a truth. So we got to keep going to see if it's consistent or not. Right, so now we're looking at the scenario where P is true and Q is false. So P true, Q false, Q false. Okay. I can circle this one, that's all done. I can circle that one, that's all done. Now what's the truth value here? Hopefully you're all thinking the right thing, right? We have a true antecedent and a false consequent. That's the only time that a conditional is false. So I'm going to make that a false and circle it. I have an F, and a T, no gremlin. Okay, keep going. Right. This time we're going to imagine F is false and Q is true. Sorry, P is false and Q is true. P false, P false, Q true, Q true. Circle the conclusion. Circle this premise right here. And what is the truth value? of the conditional, well, like I just said, right, this is the only time that a conditional is false. So if you have a false antecedent and a true consequent, that's just fine for a conditional. And if that does not make sense to you, again, just look at the table then, because it'll tell you exactly this. And I can circle it. And look what we got. All right? We have tail of green, head of red. We got true premises and a false conclusion. That means this argument format is invalid, right? And hopefully you know that too, because I might ask you on the midterm, what argument format is this? It has a name, right? Remember, you look at the second premise and ask yourself, what is it doing to the consequent or the antecedent? In this case, it's affirming the consequent. Right? And that's an invalid argument form. It's one of the ones you learned about. So we already knew, right, if you remembered that this is affirming the consequent and then that's invalid, you would already be able to predict that we would find a gremlin somewhere. Okay? And indeed we did. Let's do the final one, even though, again, it's not going to give us any more information than we need at this point, right? Once we found our gremlin, we're sort of done. But let's just do it for completion's sake. Everything is false. What's the truth value of a conditional when the antecedent is false and the consequent is false? It is still true. If you gave me $1 million, I would eat a worm, right? It's a true statement. Now, you didn't give me $1 million, and I'm not eating a worm, but it's still a true statement. Just to remind you of why that works. See how that goes? So that's the long method. But if we want to be shorter, if we want to do it faster and smarter, then we know we're really just interested in the ones where it's peeking out a little red head, right? We know that this is not a gremlin automatically, right? Because gremlins always have false conclusions, right? Redheads. So these are out. We don't need to look at those at all, right? So let's just look at a scenario where P is false, right? Remember, that's the first step. Let me write out the equation again. If you follow along the steps that I outlined in the Prezi last time, right? Let's just do it that way, and then we can compare after. First step, make the conclusion false. Boom. Right. So when we talk about making the conclusion false, I'm always worried that people are wondering, how can you just do that, right? Well, this is what we're doing. I'm not really making it true or false. I'm just saying, let's look at these over here, right? Let's see if one of these has true premises. Right? And so your first step is make the conclusion false. Then as soon as you have your truth value locked down for any of the variables in the conclusion, in this case that's really easy, we didn't have to do anything else, it's already false. Once you have it locked down, then you've got to transfer it over. We're staying consistent. Okay, just like that. Then your next step is to see if you can make the premises true, which is basically just to say, if you were to look at here, you'd want to see if there's a row where all the premises are true, right? That's what we just did. We found one, so we know what's going to happen. But let's just keep going. Your first option, the first premise that you should try to make true should always be the really simple ones, like a simple variable or a negation. Negations are really easy to deal with, or conjunctions as well. These ones are sometimes a little more tricky, so even though in this case it would be easy, but you might put an F here or a T here, right? That would make us have to do more work, because in either case this would be true. So let's do the easy one. There's only one way for Q to be true, right? This. Boom. So now we already know we're actually looking at this row right here, right? We've already said, well, let's not look at this one because we don't care about where Q is false. That gives us no information either. We need all the premises to be true, so we're just looking at this one, right? Okay, once you have a truth value locked down, you carry it over right there. And notice it looks just like that. It looks just like this line right here, right? The third line, that's where we found the gremlin. This is looking just like it. You see that? We're just following the rules. We're just looking at one of the possibilities, transferring it over, looking at more possibilities, transferring it over until it's pretty obvious which option we're looking at, and that's this one right here. And once again, we have found our gremlin. Yeah? Okay, let me check back to the main screen. I'll do another one. But first, let me see if you have any questions. Is it making sense? The overall picture. Right? The whole point is you're checking for validity. In a valid argument, the truth of the premises guarantees the truth of the conclusion. Right? Valid arguments, that's what we want our deductive arguments to be. We want them to be valid. How do you check if an argument is valid? You check for a gremlin. Right? How do you check for a gremlin? There's the hard way and there's the easy way. Right? The hard way just has more steps to it that are not all informative. Right? The easier way is just a bit quicker. See, somebody's typing, so I'll wait a second before I go back to the screen. Oh, okay, sure. Well, it's not exactly a row that you're looking for, right? So what you're asking about, right, is this argument format, right here. Now notice it's the same argument format all throughout, right? It's if P, then Q, Q, therefore P. Right, if you were to write it out in premise conclusion format. Sorry, this got a little messy here. Right, this is what you're looking at, right? That's the argument we're evaluating, right? If P then Q, right here. If P then Q, Q, right here. Therefore P, right there. Right, that's the argument you're looking for. So when you're asking what row, it's not which one of these rows, right? Those rows don't tell you anything about that. What tells you is this right here, the second premise. Right, when you have a first premise is a conditional, and then your second premise either affirms or denies the antecedent or the consequent. Right, so the second premise affirms, because it's saying Q is true, it affirms the consequent. Yeah. So that's what you're looking at. So you're not looking at these to figure out which one's affirming the consequent. You're looking at this and then this, the second premise. This second premise affirms the consequent. Okay. Okay, good. Hopefully that is good. Okay. Okay, let's do a slightly harder one, because some harder ones will be on the final. Okay, I did not do a lot of these. They're the bracketing kind, which we did start last time. Okay. You see this? You remember the brackets? So basically, before I start it all, let me just tell you, right? This is a conditional, and it's joining two parts, right? So this is the whole first premise. You see that? That's one premise. And that premise is a conditional. And the same thing will still apply to a conditional that it always does, right? It's only false if this is all true and this is false, right? So this is a conditional. It just happens to be that the antecedent is a disjunction. You might think of an example, say, if it's either sunny or really warm, then I will go to the beach. Right? Something like that. We do use that kind of reasoning and construction, right? It's just basically saying if either this or this is true, then I will do this. Right? Then the second premise says, but I'm not going to do that. So then the final premise says, so it can't be that P and Q are both true. Right? Of course, because if they were, then R would be true. Okay, anyway, I'm getting ahead of myself. I just wanted to point out, right, you get these kind of very complex kind of statements. Don't let them intimidate you too much, right? The brackets just means that this is the antecedent and this is the consequent, and the whole statement is the conditional. And we have a similar thing going on here, right? The conclusion is a negation, right? So if you want to write down your false when you're trying to make your conclusion false, right, you put it underneath the negation. What's being negated? This conjunction right here. Right? And that's why we put brackets around it. Without the brackets, it would say not P and Q. Right? It would say that not P is true and Q is true. Well, that's not what we're trying to say here. So we need these brackets to show that this is negating the entire thing. Right? So whenever this statement is false, this is true. Whenever this statement is true, this is false. But the same rules still apply. It's still the same logic table. Now, if we were to do it's still the same truth table, right, for the negation. It still flips whatever value is right here. It's going to flip the value that you're putting underneath the connective right here. Okay, so once we get to that, you'll see. I just wanted to explain, in case you kind of forgot, how the brackets are supposed to function. Okay? So now, if we were to do a truth table version of this, look, now we have three variables, right? We have a P, a Q, and an R. And I don't know about you, but I don't want to look at 16 different possibilities, right? I just don't want to do that. Let's do the shortcut method and just look at those possibilities where the conclusion is false. And then we'll try to narrow it down and see if we can find any of the rows where all the premises are true. Right? So again, we could have this big list up here of all the different possibilities, but what we'd end up doing anyway is simply looking for all the ones where the conclusion is false and then where the premises are true. So why don't we just skip laying out the whole thing and just focus on the one where the premises are true and the conclusion is false, if that's a possibility, right? So our first step, again, if you can follow along on the Prezi that has those steps laid out, 1, 2, 3, 4, 5, 6, 7, right? However many steps I had, try to make the conclusion false. Well, what I just said is the conclusion is a negation. The conclusion is this whole statement. So the F is going to be right here. Okay? Boom. Now, if the negation of the conjunction is false, right, and the negation just flips the truth value of whatever it's talking about, then of course right here in the middle I'm going to have to put a true. And this is the tricky stuff. Okay, I'm going to slow down for a second. Do you see what we're doing here? We decided to make the conclusion false, so I put an F underneath the negation sign. Now, if that conjunction is false, if the negated conjunction is false, then the conjunction itself must be true. Right? And when is a conjunction true? Well, you should just know from your own understanding of the English language, or you can look it up on your truth tables, right? A conjunction, an and statement, is only true if both sides are true. Right? So if we're looking at the possibility where the negated conjunction is false, and therefore the conjunction itself is true, then that must mean that P and Q are both true. Okay? Let me check back with you for a second to see if that's going too fast or anything. Okay, nobody has an outright problem with it. Okay, then I'm going to assume you're just following along. Then this next step is if you have the truth values of any of the variables locked down, which we do, P and Q both have to be true, then you transfer them over, right? So I simply go P is true and Q is true. Okay. My next step is to see if I can make the premises true. And again, making them true, it just means, oh, we're trying to find those logical possibilities, those quadrants or whatever. Now they're no longer quadrants because there's 8 possibilities, and quadrants is just 4. But we're trying to find those logical spaces, right, where the premises are true. And we know that at least some of them are going to involve true premises, in most cases anyway. So we're just trying to see, okay, well, then we're looking at the possibility where not R is true, right? Because again, you go for the simple ones first, right? For example, if it had just said R, very easy just to write a T under that and you're done, right? Or if you have a not R, that's really easy as well, because you can just, there's only one way to do that. There's only one way to make a negation true. That's like this, where R is false. You got that? Right? So that's that step where we try to make the premises true. Always go for the simple statements first, and then the negations, and then the conjunctions. Right? Because those all have just one possibility for making it true. So that instead of trying to work with this and looking at all the different logical possibilities, here we've narrowed it down. There's only one line where this is true, right? Given this, and then we can see what we can do for the rest of it. Right, so we've made one premise true. Now let's see if we can make the other premise true as well. Notice that we have a value locked down for R, and as soon as you do that, you got to transfer it to keep everything consistent. Okay. And now let's look at what we got. Well, we have a conditional with a false consequent. Okay. What is the truth value of the antecedent? Well, it's a disjunction. And a disjunction is true as long as at least one side is true. In this case, they're both true. Yay, that's great. So the whole thing is true. So what we got here is a true antecedent and a false consequent, which makes the whole first premise false. So there is no gremlin here. The argument is valid. Again, maybe you would be able to see that just by looking at it, right? Because the first premise says that if either P or Q is true, then R is true. If either one of them is true, then R will be true. However, R is not true. Right? So therefore, it means that neither P or Q can be true. Because again, the first premise said if either of them were true, then R would be true. Right? So it's basically a version of modus tollens, right? Denying the consequence. Do you see how that's happening there? It's a fancy version of it, but that's pretty much basically what it is. So, same procedure each time, right? Make the conclusion false, right? Just check in on those quadrants where you see a little red head peeking out, right? Focus on those, right? Just by writing down an F and then filling out everything else, transferring it over, then trying to make the most simple statements true first, and filling out the rest of the variables, and then working with the more complicated ones. Okay, I'm gonna have one more like that, but I'm gonna check up on you for a sec. Okay. The negation thing, yeah, I know. Well, even when I talk about it, sometimes I say it wrong, right? So I've gotten used to just easily switching the truth value, because that's all it does. But yes, even when you talk about negations, it can get confusing. When I say it's not P, it's not P, right? Okay, I'll wait a second here. No, Prezi's still not working. It's so weird how it does that. What other program in the world does that? You shut it down for a second, just in a normal way. I didn't even force it shut. And then it's just like, well, I'm not getting back up again. Okay, well, let's do this one, and then I might have to restart my computer, okay? What I had to do last time. But let's do another one. Okay. Another one with brackets, just to show you, right? So do you see what's going on here? Second premise, nice and easy, right? It's just P. This first premise, what kind of statement is it? It is a disjunction, right? It's right in the middle. It's not inside any brackets. That's one trick, one way to tell you, right? If you get confused with the brackets, You're like, what kind of statement is this supposed to be? Look for the connective that's not in any bracket. That's the sentence, right? So here's a connective that's not inside a bracket. What connective is this? A disjunction. So we know that the whole first premise is a disjunction, which means that if we're going to try to make this true, at least this conditional or this conditional will have to be true. You see that? So we have a disjunction with a conditional as a left disjunct and another conditional as a right disjunct, right? And then we have a conditional just by itself as a conclusion. Yeah. So we just do our normal steps. First step, make the conclusion false. The conclusion, again, is this conditional that says if Q then R, which you put underneath the connective, of course, right? Make it false. All right, we're looking at the quadrant where we see a little red head peeking out. Yeah? And then we're going to want to see if the rest is green or not. All right, so if our conditional is false, hopefully you know, right? There's only one way to make that happen when it's a conditional. That's by making the antecedent true and the consequent false, right? I should circle this. Okay, so we've made our conclusion false, and that has led us to these truth values for Q and R. It couldn't be anything else. That's why it's very tricky when you have a disjunction as a conclusion, because then you got to look at more possibilities. I won't do that to you. I want to just stick to the easier ones, where at least in the conclusion there's only one way to do it. And that's nice. With a conditional, it's like that. There's only one way to make it false. Right? Where Q is true and R is false. True antecedent, false consequent. Right? This is the scenario where you gave me $1 million, but I'm not eating a worm. Right? Well, that would make my earlier statement false, right? I had said that I would eat a worm for $1 million. So that would make it false, right? That's the only scenario that would make it false. Okay, well then we have our values for Q and R locked down. So let's just distribute those. Q is true. R is false. Okay. Next step is make the premises true. And when you do that, again, this is important, do the simple statements first if there's any simple statements. Then do the negations if there's any negations. Then do the conjunctions if there's any conjunctions. Okay? So, are there any simple statements? Yes, P. Right? Okay, that's really easy. True. Boom. Okay? Okay, so we have our truth value for P locked down. So let's just transfer it over. P is true. P is true. Okay? Now we're almost done, right? Because we just have to fill in the truth values for each of these, for each of the disjuncts, and then we will know the truth value of the whole disjunction. So when you have a conditional with a true antecedent and a true consequent, of course it's true. Right? Yes, it is. But if you have a true antecedent and a false consequent, again, right, just like over here, that's the only time that a conditional is false, so we put a false right here. So sometimes, you know, if you hard to keep track of everything, right? I'm using circles for the actual premises and conclusion. You might also, if you're dealing with something big like this, you might tell yourself, oh, this is the one that's important, and underline it or something like that, right? So then when you look at the whole, when you look at the disjunction, those are the values you're looking at. Disjunct 1 is true. The left disjunct is true. The right disjunct is false. Now, what do you get when you have a disjunction with at least one true disjunct? It's true, right? At least one of the disjuncts was true, so that makes the whole disjunction true. Okay. So, if you now look at the circled values, you'll see a TTF, right? A green, green, red. We got a tail of green and a head of red. We have found a gremlin. This argument is not valid. Okay? Yep. Boom gremlin. Yeah, exactly. Okay. Did anyone want me to address something specific about that whole procedure? Is there a part of it that's not making sense or anything like that? It's a good time to let me know, because I could try to address it directly. Also, I know some people have emailed me about assignments and turning them in late, and I'm pretty much saying yes to those, but it's taking me a little while to get back to everyone. So if you send me an email and I haven't gotten back to you, I'm sorry about that. I'm just inundated by people having problems keeping up. So I'll get to it eventually, okay? And I will allow people to do work if they missed it, if they're willing to do it. It just might take a little bit for it to show up in the grade book and all that stuff. Okay, so you mean the truth tables for the disjunction, the conjunction, the conditional, and the negation. You're a little iffy on those. Yeah, okay. But, at least you can have a cheat sheet, right? There's just 4 of them. You can put them all in a little post-it even, right? So when you take your final, you don't have to think too much about that. It would be nice, though, of course, for you just to know the truth tables, right? I keep forgetting to just make a little cheat sheet for you that just tells you the rule in English for each of them, right? Conjunction. Only true if both conjuncts are true. Right? False in all the other rows. A disjunction. Only false if both disjuncts are false. True in all other cases. Conditional. Only false when there's a true antecedent and a false consequent. True in all other cases. Negation flips the truth value of whatever is being negated. Okay. Yeah, you can have notes. Yeah. I mean, how would I check anyway, right? Honor system, but that, most people would not honor that anyway. But no, yeah, you can use your notes. You can use the book. You can use whatever you want, because that's not the hard part necessarily. It's actually using your brain to do the logic, right? If you need a little refresher for how that symbol works, that's okay, right? Although again, it would be nice if you did just know them, Yeah, I know. I'm constantly on the search for a good book to use, and there's good parts of the book, but then there's other parts it just does not do that much of the propositional logic the way that I'm used to doing it. So, yeah, I apologize about the book. I wish it was better. Yeah, and everyone does it slightly different. It's true, right? There's slightly different ways of doing it. I know. Okay, well then, I just wanted to do that for your benefit, just some review. Unless you have a specific thing I can help you with on this, like the negations. Can we do those somehow? I'm not sure how I can help you do the negations, Anna, for example. Other people have problems with that too. Okay, the review today helped. Okay, good. Good. Now, last session, there was no sound for some reason when I was recording. So that's why I wasn't up. But this will be up. So hopefully, if you get kind of forget how to do stuff, just watching me go over it later might help you as well, right? I just did 4. And you could pause it and really look to see what I did. So I encourage you just to check out today's lesson again, right? Just skip through the parts, skip over all the talking that I do, get to the meaty parts, and that might help as well. Okay, so unless there was another specific question about anything that might be on the final, other than that, I want to move on to doing categorical logic, right? Move on to that a little bit. But let me wait and see. Yeah, is everyone okay with that? Well, so I'm going to have to restart my computer and do it all. So why don't you take 5 minutes and I will have to just invite you all back again, okay? So take a 5-minute break and then I'll invite you to a new session, okay? Okay. So I guess that means there'll have to be 2 videos. So remind me to start recording when we get back, okay? If I don't remember. All right. See you in 5.